This problem gives us the formula for the position of a particle as it moves along a y-axis, and different parts of the problem ask us various questions about its velocity or acceleration. We're going to want to find a formula for the velocity of the particle, so we're going to have to take the derivative of the position formula. So we want to find v of y of t, and it's going to be equal to the derivative of y with respect to t. This is a fairly simple chain rule derivative. We have the sine function, so when we differentiate sine, it becomes cosine, and then there's the 2 centimeters on the outside. So 2 times the cosine of pi t over 4. And then to take the chain rule, we also have to multiply by the derivative of the inner function. So we multiply by the derivative of pi t over 4 with respect to t, which is just pi over 4. And then this 4 will cancel out with this t. 2 over 4 is just 1/2. So this can be much more simply written as pi over 2 multiplied by the cosine of pi t over 4. Now the first part of this problem asks for the average velocity of the particle between the interval of 0 to 2 seconds. Now because our functions are sinusoidal, that means the acceleration is not constant. So we're going to have to use the more general formula for average velocity using integration. So that formula tells us that the average velocity of something for a certain interval is equal to 1 divided by the time difference. So we're going from 0 to 2 seconds. So that's a time interval of 2 seconds. Multiplied by the integral with the bounds of integration being that time interval. So 0 to 2 seconds. The integral of v sub y with respect to t. And so the function we're integrating, so the 2 is on the outside. Pi over 2 is constant, so I'm going to pull that on the outside as well. So it's 1 over 2 multiplied by pi over 2 multiplied by the integral from 0 to 2 of the cosine of pi t over 4, all with respect to t. We can solve this integral using u substitution. So we'll say that u is the contents of the cosine function. So u is equal to pi t over 4, which means that du is equal to the derivative of this with respect to time. So pi over 4 multiplied by dt, which means that dt is equal to 4 over pi, all multiplied by du. So our integral becomes 1/2 multiplied by pi over 2, multiplied by the integral of 0, and we're going to want to convert the bounds into u's as well. So using this formula, putting the 0 in for t, we get u. Putting in 2 as our upper bound for t, we get pi over 2. So our upper bound becomes pi over 2. And the actual contents of the integral are the cosine of u, multiplied by 4 over pi du. To simplify this further, we're going to cancel out the pi's, and the 4 will cancel out with the 2's, since 2 times 2 equals 4, and 4 divided by 4 is just 1. So our integral simplifies down to the integral from 0 to pi over 2 of the cosine of u with respect to u. And then from here it's pretty straightforward. The antiderivative of the cosine is sine. So we've got the sine of u with our bounds from 0 to pi over 2. So we just apply the fundamental theorem of calculus. Sine of pi over 2 minus the sine of 0. And using basic trigonometry knowledge, the sine of pi over 2 is 1, and the sine of 0 is 0. So 1 minus 0 is just 1. So 1 centimeter per second is our average velocity. Part B of the problem asks for the instantaneous velocity of the particle at t equals 0, 1, and 2. Fortunately, this part of the problem is much more straightforward than part A. We don't need to do any integrals. We just need to plug in 3 different variables, or 3 different values in for our variable in our v sub y equation. So first off, we're plugging in t in for 0. So pi over 2 multiplied by the cosine of 0. The cosine of 0 is just 1, so the answer here is pi over 2 centimeters per second. Next, we're plugging in 1 second. So the formula is pi over 2 multiplied by the cosine, and then we're plugging 1 in for t. So the cosine of pi divided by 4. And the cosine of pi over 4 is equal to radical 2 over 2. That's the square root of 2 divided by 2. So multiplying these together, we get pi multiplied by the square root of 2 divided by 4 centimeters per second. And lastly, for part B, we're going to plug in 2 seconds in. So pi over 2 multiplied by the cosine of, and this time we get pi divided by 2 for the inside of the cosine function. And again, using trigonometry knowledge, the cosine of pi over 2 is just 0. So this whole thing becomes 0. 0 centimeters per second. And that is our answer for part B. Part C asks us for the average acceleration of the particle from 0 to 2 seconds. So we used a derivative earlier to find a formula for the velocity. Now we're going to need to take the derivative again to find a formula for acceleration, because the formula for acceleration is that it is the derivative with respect to time of velocity. Once again, this is a pretty basic trigonometry derivative. Recall that the derivative of cosine is negative sine. So we've got the pi over 2 on the outside, but then we make it negative and multiply by the sine of pi t over 4. And then to apply the chain rule, we multiply by the derivative of the inside. So we multiply by pi over 4. And then multiplying the constants together, this more simply becomes negative pi squared over 8 multiplied by the sine of pi t over 4. So to find the average acceleration between the points of 0 and 2 seconds, we're going to apply the same method we used before. The average acceleration is going to be multiplied by 1 divided by the time interval. So 1 over 2 seconds, multiplied by the integral, bounded by that very time interval, of the acceleration with respect to time. So putting in our acceleration formula, the 1 over 2 is still there, but then we're going to bring out the negative pi squared over 8. Negative pi squared over 8. And the integral, again, from 0 to 2, is the sine of pi t over 4 with respect to dt. And once again, to solve this integral, we're going to use u substitution. So once again, I'm going to set u to be the contents of the sine function. So pi t over 4, which means that du is equal to just pi over 4 dt. And so dt is 4 over pi du. So putting all this into our integral, the 1 over 2, negative pi squared over 8. Here's the integral. And again, we're going to reset the bounds by plugging in 0 and 2 into our t to u formula. So 0 into t, that's 0 times, anything times 0 is 0. So the lower bound is still 0. But then the upper bound being 2, we put in the 2 for the t. So that's 2 pi over 4, which is just pi over 2. So the upper bound is once again pi over 2. And the thing we're integrating is now sine of u multiplied by dt, which is 4 over pi du. This pi cancels out with one of the pi's since it's squared. And then the 4 will cancel out with the 8 to become like a 1 over 2 thing. So our new simplified integral is 1 over 2 multiplied by negative pi over 2 multiplied by the integral from 0 to pi over 2 of the sine of u with respect to u. I'm going to condense the stuff at the beginning, multiply the 2's together, so that instead it's read as negative pi over 4. And the integral is once again a fairly basic trig integral. The integral of sine, or the antiderivative of sine, is negative cosine of u, with our bounds of integration being 0 to pi over 2. So now we just apply the fundamental theorem of calculus on this. So we've got negative pi over 4 multiplied by, and then we plug in pi over 2 for, we do the upper bound and then minus the lower bound. So that's negative the cosine of pi over 2 minus negative the cosine of 0. Now, the cosine of pi over 2 is just 0, then minus a negative is just a plus, so plus the cosine of 0, which is just 1. 0 plus 1 is obviously 1, so our final answer is negative pi over 4. So our average acceleration is negative pi over 4 centimeters per second squared. And that is our answer to part C. Finally, part D of the problem is another fairly simple part, just like part B, where we're just plugging in different values in to find the instantaneous acceleration at different times. For 0 seconds, this is just negative pi squared over 8, multiplied by the sine of 0. The sine of 0 is 0, so this just gives us 0 centimeters per second squared. Then we want the instantaneous acceleration at 1 second. So again, we're just plugging in 1 for t. So negative pi squared over 8 multiplied by the sine of pi t over 4. We're putting in 1 for t, so it's just the sine of pi over 4. Now, using some basic trigonometry knowledge, we know that the sine of pi over 4 is equal to radical 2 over 2. So our answer for this simplifies to negative pi squared multiplied by radical 2 divided by 16 centimeters per second squared. And finally, we want to find the acceleration at t equals 2 seconds. So again, negative pi squared over 8 multiplied by the sine. That's the sine of pi t over 4. So putting in 2 for t, that's 2 pi over 4, which just simplifies to pi over 2. And using trig knowledge, the sine of pi over 2 is just 1. This is just the negative pi squared divided by 8 centimeters per second squared. That is the answer to our final part of part D, and that is the answer to this problem. That is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I hope you all have a lovely day. Bye-bye.